So as a refresher, in C++, to create an array, you specify the data type, you give it a variable name, and then you specify the length. If you want, you can give it an initializer list of values to stick in there. Right, so that would put the values 1 and 20 in our array, but we said it was 5. So what's that going to put in it? It's going to put a 1, a 20, and then it's just going to pad it out with zeros. And by the way, guys, Java doesn't work like that. 1, okay, 3 more zeros, like that. If the initializer list is less than the size of the array, that's what it does. Pads it out with zeros to the end. So a quick way to wipe out the array is just to do that. Give it an initializer list. All it's got is one value, which is a 0, and then the entire array becomes blanked out. Why would you want to do that? Because otherwise, if you create an array as a local variable, you get garbage values in it until they're reset to 0. Whatever happened to be sitting in those bytes on the computer at that time is what's in the array. If you are going to use an initializer list, you don't have to specify the length of the array. You can just go, you fill that in, Mr. Compiler, and the compiler would go, okay, you have 4 pieces of data there. Now I'm going to make the array 4 long. And again, for 2 and Vincent, if you were doing it in Java, you just have to move those braces there. Would be the exact same thing. So a range-based for loop. That's how you iterate through an array without using an index. We've already done iterating through an array using an index, right? If we do this, int size of the array is equal to 10, and then we declare an array of ints, an array of doubles, AD for array of doubles, and we make it that long, and we set it equal to some values, right? I don't know if that's 10 or not, whatever, you get the idea. Then we want to print it out, we use an index. For int I is equal to 0, I is less than the size of the array, I++, and then we write that out. Cout AD subscript I NDL. But if we are in the same context, if we're in the same scope in which the array was declared, we can also use a range-based loop, which in C# is called a for each loop. And I believe Java calls it the same things. And you've seen this syntax in Python as well for you couple of folks who've taken Python. For double value colon AD. That means for every or for each double in AD, print it out. Cout value. I'm going to take the curly braces out so that these two things look exactly equivalent. Now, to my mind, this is cooler than this. I like this. I don't have to, the syntax is cleaner to me. Every element in the array is copied into this temporary value, this temporary variable called value, so that we can undo it. Now when I say copy, I actually mean that. If we have the index value, we could reset those variables. We could change the values of them as we pass through them, like this. Like what if I wanted to add 1 to every value in my array? Well, I would have my, my for header, and then AD subscript I equals AD subscript I plus 1. Or I could just shorten that to AD subscript I plus plus, That would add 1 to every value in the array. Great, but what if I wanted to do that with a range-based loop? For double, for every value in the AD array, add 1 to the value? That doesn't do it, because value is just a copy of the element. It's not the original element. You can hack it so that it works, though. You can make this a reference. You put an ampersand there, and that says it's not a copy of the value, it's the original value. And people who are sitting in my Java class notice that since Java does not have the reference operator, you can't do that, but you can in this language. If you want to actually change the values of the array as you step through it, declare your for each loop, your range-based for loop as a reference. If you're not, if you're just going to print them out or sum them up or something like that, then you don't have to do that. So you use a reference operator in your range-based for loop, also known as a for each loop, if the elements need to be changed as you iterate through them, as you traverse the array. So the range-based for loop, it iterates once for every element in the array. The array value is copied from the array to a built-in variable, a temporary variable known as the range variable. And the range-based for loop automatically knows the number of elements in the array. We don't have to figure it out. We don't need a counter. We don't have to worry about stepping outside the bounds of the array. We don't need to worry that it's going to go past the end of the array. The only bummer is that it doesn't work if you're inside a function and that array is being passed to you as a parameter. If it's being passed to you as a reference, you could still do it. So the general format of the range-based for loop. Date for, and then the data type like int or string or whatever, range variable, that temporary variable name, colon, range array, and then you do some statements. And by the way, in C#, it's the exact same syntax except you put the word each there. You put I in there. I love that syntax, but that's not what we have here. That's what we got. So here's our declaration of our array. Int numbers, empty subscripts is equal to that. So we have an array of 5 elements long. And then we want to print them out. For int val, I had value. Variable names don't matter, right? It could just be v. Int val colon numbers for every int in the numbers array. Print it out. So as the range-based for loop executes, its range variable contains only a copy of the element. So you cannot use a range-based loop to modify the contents of the array unless you declare the range variable as a reference. To declare the range variable as a reference, you use the ampersand. Like what if we were going to ask the user for some values? Well, we could use an index to store some values in it, or we could use a reference range-based loop. Let's do the latter. Why won't it let me shrink it any more than that? Okay, there we go. No. What lecture are we on? We're on R already. R, matey. Empty project. Lecture R. Boilerplate. New file, new item. All right. Let's declare an array and let's wipe it out. Let's fill it all with zeros. So I'm just going to call it names. So string name subscript 5. I don't know if that wiping out means anything when you're dealing with names, so strings, I'm just going to leave that like that. Now, let's tell them that they need to enter some names. And let's just write the loop and tell them inside it. So for parentheses, string v for value, colon names in parentheses, But since I wanted to actually be able to change the values as we're stepping through them, I need to declare v as a reference, meaning I need to put an ampersand in front of it. And so let's see out a message, enter a name, colon, space, end quote, semicolon, and then CIN, arrow, arrow, V. Now that looks weird to me. It doesn't look like it would store those values in an array to me. But that's because I've used languages too long where you didn't have the ability to make reference variables and use them in a for each loop. Now let's print them out. For parentheses string, and we don't need to use a reference here because we're not modifying the values. We're just printing them so we can use a read-only, a copy version of it. So string v, colon, names, cout, arrow, arrow, v, arrow, arrow, quote, space, quote, semicolon, and then after our loop, let's print a character turn. So cout, arrow, arrow, ENDL.
So are you not setting a value into names?
Isn't that weird? I never do it this way personally, and I'm probably not going to demonstrate it again. But let's make sure this works. Joe, Bob, Ann, Sally, Sam. Yep, it works. The reason why is that when this is iterating through it with the ampersand, meaning a reference, then V actually is the first element in the array. And then it actually is the second element in the array, and the third element in the array, and so on. If you're not going to use a for each loop, if you're going to use an index, this is how you would normally do it, and this is how you would do it in all the other languages I've ever used. I'm going to comment this out, and we're going to use an index-based loop in order to do it. So for parentheses int I is equal to 0, I is less than 5, I plus plus. Now I hate the fact that I just hard-coded a 5 there. I should have declared that as a constant somewhere up above. And then let's see out, quote, enter a name, colon, space, end quote, semicolon, and then CIN, arrow, arrow, names, subscript I. And that's what you were expecting it to look like, Vincent. I know that. That looks much saner to me. I don't have an argument for doing it the first way, except just to flaunt that we understand an arcane syntax. But after you start using range-based for loops a lot, or for each loops, then maybe you would kind of like that because it preserves the convenience of that. When can you not use a range-based for loop? You can't use a range-based for loop if you have to have that index, right? Because we don't have an index here. So like if we're looking in two arrays, if we're looking at parallel arrays, right? We're looking at a list of names and then their favorite foods. Well, we need to tie them together by their index values, and we can't use a range-based loop that way because we don't have an index that would be able to tie them together. And I think I cut somebody off who was about to ask a question as I began to say that. Is that true? Nope. Bummer. Not bummer that I didn't cut you off. I was hoping for a question. Let's save our data to a file. So let's scroll up and declare, or let's do a # include fstream so that we can write our stuff out to a file. # include fstream.
Wait, don't you already have fstream?
Oh, what do you know? It's in my boilerplate. It wouldn't cause an error for me to do it again. All right. Now we need to open the file. So ofstream fout, or out file, or f, or whatever. And then fout.open. Let's give it a file name. names.txt. And let's use the range-based loop to dump all of our names to that file. Oh, I want to move the cout ENDL above my OF stream declaration. I consider it part of this loop here. Why did I put the ENDL here? Because I don't have it inside here, because I wanted the names printed horizontally rather than one per line. Same thing's going to go on now, though. We've got our file open. We should make sure that it's a valid file. So if, parentheses, f out, in parentheses, curly brace in, curly brace, f out, arrow, arrow, v, arrow, arrow. And let's do just one per line. So f out, arrow, arrow, v, arrow, arrow, ENDL. And then once, wait, that's not going to work. I needed my for loop. I don't have my for loop yet. So above that, for string v colon names, f out, arrow, arrow, v, arrow, arrow, ENDL. And then after our for loop, we need to close the file. Always close your file as soon as possible, as soon as you're done reading it or writing to it. All right, that was just a reminder of how to save data to a file. We could open that file and we could reconstitute a new array. It's called serializing your data. I'm not sure who came up with that term, but you're serializing your data. You dump it to a file, later on you reconstitute it, you bring it back. Are we all good, or does anybody need a pair of eyeballs on the screen? We all good? Nobody's waving their hand. So here's the PowerPoint's example of using the range-based for loop for data entry, just like I did. And like I said, that looks wrong. I'd rather see numbers subscript I here. Right. That looks better to me. If you want, you can use the auto keyword inside the range-based for loop. You don't even have to know what type of array you are stepping through in that case. So I could go back to all of my range-based for loops. I don't have that many of them, but there was one commented out here, and instead of saying string, I could put auto there. And instead of int, I could put auto there. Now, I don't have a strong reason for wanting to do that. I don't mind knowing that it's an array of, well, that's wrong. It's supposed to be string. Yeah.
Can you do that with any loop? Can you do that with any for loops?
Pardon me?
You can't do that with, well, I guess you wouldn't need to in for loop because you're using an actual.
Right, but if I wanted to, I get what you're asking. Could I do that anyways? For int I is equal to 0, I is less than size, or 5, whatever. I plus plus, you're right, auto value is equal to names subscript I, like that. And it does the same thing.
Okay.
This is pretty much an exact duplicate of this right here. Once we're at this point, you don't have to type this in. This is the exact same as this loop here. It copies all the values one by one into a variable named v, and then we can use it. So the range-based loop versus the regular loop. Range-based is great when you need to step through the elements of the array, but you don't need the subscripts. You don't need the index values. But if you do need the subscripts, use the regular for loops. So let's come up, now that we have 5 names, let's ask for 5 ice creams, 5 favorite foods, 5 favorite colors, something like that. So we're going to write we're going to create a parallel array, which is an array of the same length. And the arrays are going to be thematically linked by their index values so that the first name and the first food go with each other and the second name and the second food go with each other. So we need a second array the same length as the first one. Now, I'm getting really tired of the fact that I've hard-coded that to a 5. I'm going to fix that. I'm going to highlight that and do a search and replace for every occurrence of 5. Control H, 5, and I'm going to replace that with size, right? Now, the Mac users, I don't know how you do a search and replace. I'm sure that you know. And then click that little button, replace all. But I better define size then for that to work. So int, or even const int size equals 5. Why do that? What if we decide we want 10 names, 20 names, 30? I don't want to have to go through the entire code changing all of those 5s to 10s or 20s or 30s. Okay, so let's create a parallel array called food. Listing the food for each name. So food are also strings, so it's also going to be an array of type string. It needs to be the same size. And since I need to ask, like, what is Bob's favorite food? What is Sam's favorite food or whatever? I'm going to need an index value, right, so that I can associate that name with whatever element I'm writing. So it's going to be yet another for int loop. For parentheses int I equals 0, I is less than size. I plus plus, we type that so much, we should just copy and paste it. Let's ask them a question. Cout, arrow, arrow. What food for, space, end quote, arrow, arrow, names, subscript I, arrow, arrow, quote, question mark, end question mark, semicolon. And let's store the result into our new array. So cin arrow arrow food subscript I. Now, although I like range-based loops, although I like for each loops, to print them out side by side so that John likes spaghetti and Sam likes pizza, I'm not going to be able to do that because, again, I need the index. I need the subscript to link the two. So that name 0 is associated with food 0, name 1 is associated with food 1, and so on. So yet again, getting tired of that, I'm going to copy this for loop. For and let's see out the name. So names subscript I, followed by maybe a tab. The cheap way of trying to line things up. So arrow arrow quote backslash t end quote arrow arrow food subscript I arrow endl. Now, what would be the right way of doing it? Not relying on tab. If I want to print this out as a report and they all line up, what should I be using? Set W and IO manipulators so that we could set a minimum length.
Is this all within the if f out loop or?
Oh, I'm sorry. I left that loop. This is completely outside of that. I closed my if f out and then I started babbling on about the parallel array. But nah, I'm not going to restructure anything. Just going to leave it alone. Let's see if it works. inner name. Sam, Sally, Sue, Bob, Jill. All right, what food for Sam? Pizza, kale salad. Oh, check out what happened there. Why did it do that? I typed in kale salad, it skipped Sue, and now it's asking Bob.
You type, the CN is for the whole line, so.
Right, CIN, arrow, arrow just gets the first word, and so the second one is left out in the buffer, and so it's going to say that Sally likes kale and that Sue likes salad. Alrighty, and Bob likes cookies. Jill likes Doritos. Whatever. And there we go. Now we could create as many parallel arrays as we wanted to. First names and last names and middle names and addresses and food and whatever, right? Age, height, weight, and so on. But I think that's a good enough example. By the time you're creating more than 2 parallel arrays, you need to come up with a different solution. That solution would probably be to create a structure, and then have an array of structures, which you can do. Let's give that a shot while we're talking about it. I know the book doesn't talk about that, but we're better than the book. I'm going to create a structure and I'm going to call it name food because I'm really not coming up with a better term than that. You know what, I may bail out of this real fast. So string name, string food. Now let's create an array of this type. So name food items subscript 5 or size. Size was in all caps, wasn't it? And now we could start filling in those values. Item subscript 0 dot name is equal to Jennifer. Items subscript 0 dot food is equal to hamburgers. And so on. Item subscript 1, item subscript 2, 3, 4, and 5. I'm just going to copy and paste and start filling them in. And I'm tired of typing, so I'm going to change this from being size to just being 3, right? Now we have 3 items. We have 3 pairs of data. Name, food, name, food, name, food. It's no longer a parallel array. It's a single array where every element has 2 pieces of data. Now if I was cool, I would declare struct outside of main. I would put it in a header file so that it could be used by multiple functions and multiple files. But it's okay to declare a structure inside of a function. It just means that it can't be used in any other function in the same or other files. Just like a local variable, right? If I declare something in main, it's not going to be accessible by any other function in that file. Alrighty. Now we're going to write a range-based loop to print these out. So, for Now what is the data type of this array? It's not strings. This is an array of what? What type did we declare our array as?
Struct.
Yep. I wonder if that would work if I typed in struct name food. That's what you would have to do in the C language. The C++ is smart enough to know, to figure out that it was a structure based on name food. So for name food, V for value, something like that, colon, items, C out, arrow, arrow, V dot name, arrow, arrow, quote space, once, space, quote, arrow, arrow, V dot food, arrow, arrow, ENDL. I'm wanting the ideas of structures to become old hat by the time we actually hit the chapter on them. Like it's not going to be on the exam or anything, right? But enter a name. All right. Bob, Sam, Joe, Sue, Jack. All right. Pizza, pie, cookies, pie, pizza. Got some duplicates there. Alrighty, and there we go. And then our array of structures. Jennifer wants hamburger, Robert wants spaghetti, Becky wants grapes. So you can see that having an array of structures got rid of the idea of the parallel arrays. Meaning that we didn't have to have an index value when we were printing them out. We could just print them out like that. Whereas when we were dealing with parallel arrays, we did have to use an index-based for loop to tie the two arrays together. And probably a good time to pause and make sure.
For some reason, I keep on getting extra once. Like, you know how we put once in quotations?
If you didn't catch me change that size to a 3, now 2 just was tough and went ahead and did all 5 of them, but I was lazy, I changed that to a 3. What if you did a combination of those things, you didn't change that and you didn't put enough, then when you run it, oh boy. This is why it gets really annoying to have programs that ask for input. There we go, you know, and then it prints out once. That's because we have an array of structures, but there's no data elements in those structures. And it's kind of a coincidence that it's even filled it out with blank data. Since those elements have not been initialized, then there could have been anything in those structures. Alrighty, so I mentioned an exam 2 coming up over chapters 5, 6, and 7. That's going to be not next week, but the week after, meaning that we'll need to have a review on the first. And the point of having a second exam rather than just a midterm and a final is because if we wait and only have one more exam, then the final is going to be a huge bunch of, huge bunch of material. And this gives us the advantage also, I may be a nice guy and say that if you're happy with your grades, you don't have to take the final. But I can't really do that if you're only taking 2 exams, right? A midterm and a final. But with 3 exams, I might say, if you're happy with your exam average, don't take the final. So anyways, I think there's some advantages to going ahead and having the second exam. Let's make sure that there are quizzes available. That's why I put due dates on them. Just remember that I will come back and remove the due dates, but that's The only reason I put due dates on them is so that when you log into the class, it'll show a list of things that are due right in the corner. A lot of people forget to do the quizzes until they see them show up there.
They're due.
Yeah, they're due on the 29th,
But it is, oh,
but I'll take the due date away once we hit the 29th. So even if you miss them, but don't miss them. All right, and then, we're going to be done with Chapter 7 pretty soon, so feel free to take the Chapter 7 quiz as well. And I hope everybody knows how to find out how they did on the exam and to look at the questions. To pull the little pull down, click submissions, and then look, because I have another class where it turned out like a third of the class had taken the quizzes and then hadn't been looking at the results before they took the exam. And I felt bad. Okay, onward and upward. Processing array contents. Well, we've already been doing this. Array elements can be treated as ordinary variables of the same type. Right? If we have, just like you could do x plus plus and it'll add 1 to x, tests subscript something plus plus adds 1 to that item. Now, you have to be careful where you put the plus plus. If you put the plus plus inside the subscripts, it changes the value of I, but it doesn't change the element. To copy one array to another, you don't do this. You don't say new array name is equal to old array name. Instead, that just gives you 2 references to the same spot in memory. Just like if you have 2 signs that point to your house. You still only have 1 house. Doesn't matter that you have 2 signs or 100 signs to it. You actually have to build a new house before you could copy, move your furniture from one house to the other. My examples always get a little bit silly. Instead, you have to allocate a new array and then copy the elements line by line. So, since we have an array called names or an array called foods, let's create a new array and copy all the elements into it. So we need to make a new element, a new array. To copy an array, and this is so exactly like you just did in Java, I apologize to you guys. To copy an array, you first make a new array of the same length, and then use a loop to copy the elements. So I'm going to make an array called new food because I'm not feeling creative. String new food, subscript size. That's going to be the array. That's the target array. So guess what? It's going to be our for index loop again. For int I is equal to 0. Why couldn't we use a range-based loop in this case? I keep saying when you cannot use range-based loops, and this is one of those cases. Why is that?
You have 2 different arrays.
Exactly, 2 different arrays.
That need to be
So we need the index value to hook them up, just like they're parallel arrays. So int I is equal to 0. I is less than size. I plus plus. New food subscript I equals food subscript I. I want to try your trick of putting that inside.
You need the minus though.
That would have to be, yeah, I'm going to undo this. I just want to see it. And then for string v colon new food, cout, new food, followed by a space, cout envl. I just got to see if that works. A new toy he showed me. Got to play with it. Well, what do you know? That's pretty wild.
I don't think it worked.
Yeah, let's undo that. I'm getting really tired of having to enter that many pieces of data. I'm going to change size down all the way down to 2. Alrighty.
I didn't get to count no.
Joe, Bob, pizza, cake. What do you know? It's printing addresses. I recognize those. I mean, those are pointers. They're addresses. They're memory addresses. Now, why would that be? Oh, you see what I'm? No, I don't see what I'm doing. But I'm going to use a range-based loop to print them out just because I'm stymied. Oh, now I see it. What's wrong with this print statement? This is very common to what students do on an exam, and now I have a great deal of sympathy.
Should it be CIT?
Exactly. I should be printing out my range variable. Now it's going to work, and now the other weird syntax would have worked as well. All right, that worked.
What? Why do you? No. Oh, because that's like, so string.v would be like food I or food
Exactly.
as I?
It's just like doing this. Let me rewrite it. String v equals new food, subscript I, and then printing it out. Like that. That's what the range-based for loop does, is it automates that little step right there. Which is why, if you were trying to change the value of v, it wouldn't have any effect. Like if I did this, if I zeroed out v. My original array is preserved because v is just a copy of the array. But if I made this a reference, like that, I said, no, that really is that specific element of the array, then this would wipe the array out as it was stepping through it. All right. So sure enough, you can display the contents of a character array by sending its name to cout. We haven't been using character arrays much. I think I've only broached them once or twice. Like that. Notice the difference in syntax. Every other type of array we created, we had to do that, right? In order to store them. So if I do this, char me, like that, equals, quote, Joe. That's the same thing as doing this. Char you equals curly brace, single quote J, end. This is going to get really tedious to type. I'm not going to even say it aloud. There. Those arrays now have identical data in them. This is an array of 4 characters. How do I know it's 4? Because it's 3, but a character array has to have a terminating null to indicate where it ends in memory. Otherwise, print statements and loops or whatever don't know where to stop. So instead, print statements and loops and whatever look for the terminating null. But the compiler handles that. Right, when the literal is declared, it puts that /0 at the end of it as it's copying it into that array, even though we don't see it. And I can print both of these out. Cout me, followed by a space, you, followed by ENDL. It will be the same thing. So print out JoJo. In olden days, when you learned C programming, you spent an awful long time learning how to handle character arrays because that's what you had. You didn't have strings. and he learned how to concatenate two character arrays and to copy from one to the other and to remove things from them. The string class makes that a lot easier. You know, string greetings equals, you know, this is probably not going to work. Hello, end quote, plus you. I wonder if that's going to work. Nope. I was afraid of that. All right, forget that. So anyways, the point of them mentioning that is that normally you cannot print out an array just by doing that, right? If I did cout, and we actually saw an example of that. If we do cout new food, ENDL, it's not going to print out our list of food. Instead, it's going to print out that address. But when we printed out the character array, they made it smart enough to know, oh, I'm just going to print out every letter in the string, every character in the string until I find. So a loop that would duplicate that would look like this. For int I is equal to 0, I is less than strlen. No, I'm not going to even write this. Forget that. And delete that. So partial array initialization. You can get into a situation where you have partially filled arrays. Like you decide that, you know, in this class, I may give up to 20 homework assignments, and you're going to track all your scores in it. So you create an array that's 20 elements long, but at this point, you've only had 12 assignments. So you copy those first 12 elements in. You have unused elements out to the end. And so if you want to calculate your average, you have to be careful not to include those, right? Once you add them all up, you're just going to want to delete, you know, divide by the number of good data elements, right? The 12 homework assignments, not by all 20. Otherwise, it's going to bring your average down. So when you're dealing with partially filled arrays, you need to know what position, how many pieces have been filled. So, for example, we're going to do more data entry, and I'm getting really tired of the data entry, but we've got to do this to illustrate. We're going to make an array called scores. It's going to be 20 long, and we're going to, I don't know why I'm making it that long. And I'm going to clear it out, I'm going to wipe it out, I'm going to initialize it all to 0, and then I'm going to write a little teeny tiny loop that says enter a number or -1 to quit. So I'm going to need a counter to get this to work, an index counter, which I'm going to set to 0. So for, parentheses, int I is equal to 0. I'm regretting the name index there. I'm going to change that in just a minute. I is less than 20, I plus plus. Now let's cout ask for a number. Cout enter a num or -1 to quit. Colon, space, end quote, semicolon. And let's get that input. We need a temporary variable to hold it. So int var cin arrow var. Why am I storing it in a temporary variable? So that I can check to see if it's equal to -1 before we put it into the array. And then if var equals -1, then break. We're letting them leave early, right? They have a maximum of 20 spots to fill up, but they're not forced to fill up all 20. They can quit whenever they want. Now I'm going to go back and change int index to something that indicates more accurately what it really is. Like count or num scores, score count. And I need to increment that every time they enter a piece of good data. So if var is not equal to -1, then we need to store that in the array. So scores subscript I is equal to var, and then we need to increment our counter. Score count plus plus. And you could try to get away with using the same counter, you know, as your index variable and stuff like that. But I'm going to leave it as is. Why do we maintain score count? So that if they only enter 3 scores, we know that there's only 3 pieces of data. So that when we print the array, we're only printing 3, because there's 20 spots. We could conceivably print 20 spots. And if there's only 3 good pieces of data, we don't want to print all 20. Or maybe we do, but if we're calculating an average, we certainly don't want to divide the total by 20 if they only had 3 grades. So now if we're going to add up the contents of that array, we're not going to go up to 20, we're going to go up to score count, how many pieces of data are actually there. So let's declare double sum is equal to 0, and then we'll write a for loop that'll add all the values up to score count. So our for loop's going to look a little bit different. It's just going to say I is less than score count there. For int I is equal to 0, I is less than score count, I plus plus, sum plus equals scores subscript I. And now we can calculate the average. Double average is equal to sum divided by score count. And again, if we divided it by 20, it wouldn't be the correct average. And if we did I less than 20, it'd print out a whole bunch of blank scores, scores of 0. We may as well print out the average, and the average equals space end quote error error average error error ENDL. And I would not be surprised if I've typed too quickly and left some people behind. But I guess I should test it. All right, enter name. Blah, 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 blah. Finally, I get to the point where it wants numbers. Oh, and I still have my bug there. Oh well. Enter a number. 9, 10, 11, 12. I could do this all the way out to 20 scores, but I'm going to quit early. So I'm going to type in -1, and it prints out the average. If I had divided by 20 instead of saying the average was 10.5, it would be 42 divided by 20, whatever that is, 2, right? An average score of 2, which wouldn't be too cool because it'd be counting all the zeros at the end of the array. So let's redefine parallel array. 2 or more arrays of the same length, where the elements are united by, thematically tied together by what? Fill in the blank. A parallel array, 2 or more arrays of the same length, where the elements are tied together by what? Yeah, index or subscript. Partially filled array. An array where the valid data elements do not completely fill the array. Where there's unused data elements at the end. What's a good way of putting that? Why don't I do a Control F and find out if they've got a definition for it. If it is unknown how much data the array will be holding. you make the array large enough to hold the largest expected number of elements. Right, I wouldn't need to declare the array to be 2,000 to keep track of the homework assignments in this class. That'd be silly. And then you use a counter variable to keep track of the number of items stored in the array. So I guess I'm going to declare as a partially filled array as an array where the number of valid elements does not necessarily match the length of the array. That sounds too computerized. An array where not every element has valid data. I like that. All right. In which case you need a counter to tell what the last good index value is. So to indicate how many items are good. What the last valid index is. And in that case, in the example that we had, we called that score count. All right, I think that's enough about arrays. Do we have, for today. Arrays and file I/O. I think that's probably still enough. Instead of giving y'all homework over copying an array, I'll just have y'all come in and do a quiz together with me where I ask that on Tuesday. So on Tuesday, be able to write code that will print an array using a loop and that will copy an array. I really should give some homework. Feeling guilty about not doing homework. But I didn't quite lecture up enough about parallel arrays to get to the point where I want to give you your next assignment, so we'll stop there.